I am, as you said, coming from France. Despite my accent, which is not French, I have been in France for about 20 years, and I work with INRIA, which is the French National Research Lab in Computer Science. And I direct a lab called ExSitu, and we do all kinds of different things. So I will talk about a very focused piece of our work today, but we do everything from very tiny objects to wall-size and immersive displays. We do interaction techniques, we deal with users, we do participatory design, distributed communication, and we build a number of interesting engineering platforms. Again, later. So, when we think about what we were seeing in the keynote, that was very interesting to me because I started my career as an experimental psychologist and studying reinforcement learning in human beings. And the thing that's interesting is that, of course, we can learn a tremendous amount from how human beings learn when we're trying to build interactive systems. But I think we have to keep in mind that there's always a human being in that loop. And so the question is, what is the role of the human being in this interaction with computers? So Hollywood has some answers to that. We have Tom Cruise here, interacting with, actually experimentally, what has been determined to be a really bad interface, but it looks really good on screen. We also have Robert Downey Jr. He's empowered by wearing these suits and all kinds of wonderful things. So AI, intelligent systems, fabulous. And then we have things like this with Wall-E, where that's a different, rather dystopic version of what happens. So if you have an AI system that just delegates all the tasks, what's the role that's left for human beings? So the thing I wanted to talk about a little bit is this notion of a partnership between a human being and a system. A human being, with respect to something that we all understand, transportation, that's a machine, right? So we can think about what is our role with respect to transportation. I can take a taxi, and this is a really good idea if I've been drinking late Saturday night and I want to get home. I want to put the driver in control. I want to delegate that responsibility to somebody else. However, what if I enjoy riding motorcycles? Now that's a learned skill. That's something I want to do, that's something I enjoy doing, and I'd better not do it if I'm drunk. So there, I have 100% of the responsibility. I need to be in control as a human being. The third possibility is some kind of shared control, a partnership. This is kind of a different model of AI, not so much the idea that we hand off everything, we delegate everything to the computer, but rather that the computer is good at doing the things the computer is good at doing, and I, as a human being, get to remain doing the things I enjoy doing and want to do. So if I'm drunk and I have my horse, the horse will take me home. But if I want to go galloping on the beach, I can do that. I can start out not knowing the horse very well, the horse doesn't know me very well, and then over time, we both learn about each other. So there's a whole different kind of relationship that we can think of as a vision for the future. So that's where I think we're going. But I want to, so I hear all of this stuff about self-driving cars as if that's the only future that we've got in transportation. But nobody is going to buy a self-driving Ferrari. That's just not the point. So if we think about research in computer science, we have three basic kinds of research with respect to how we interact with computers. The first one is what's called human-computer interaction, which is primarily my field. And here we think about the computer as a tool. And the goal is how to empower users, how to let people do things better. In the early days, it was how to make them more efficient. Now we're thinking about ways of making them more creative or helping them be creative and do new things. There is, of course, AI, and that's the idea of computer as a servant who goes and delegates. We delegate tasks, and they perform them for us. And the third one, which I won't go into much detail today, but the idea is it's a medium. So social media, Skype, all of that distributed communication, it's a medium for communication between and among people. So if we take an AI perspective, a traditional AI perspective, there's this talk of the human in the loop. And when I talk to my colleagues in AI, they're very proudly saying, well, we do think about the human being. Really, we do. But the way they think about the human being is as input to their algorithm. And they don't actually measure the impact on the human being. They simply measure the impact on the algorithm. And if my algorithm is faster and more efficient than yours, I publish the paper and I win. All right? Now, that leads to a lot of this. We get a lot of systems out there that are extremely difficult for people to use, or really boring, or really cumbersome, and they slow people down. And it's because we're not thinking about how to empower the user, we're thinking about how to get a better algorithm. So we need to do both. We need to think about what I call computer in the loop, where the algorithm is input to inform the user. And then both the algorithm can learn and adapt to the user, but the user can learn and adapt to the system. So what we want is to not just create models of users, but also create models of the system and represent them in a way that makes sense to human beings. So we want to augment human capabilities as a tool, and we want the computer as a servant to take over our undesirable and cumbersome tasks, but somehow keep the user in control of that process. And that's the key challenge, I think, for AI these days. All right, so if we think about designing an interactive system that a human being will use to accomplish something, perhaps a creative task, the idea is that you would like it to be the case that simple things are simple and complex things are possible. So we have this nice little curve where the 0 point is not very simple and more simple, or not much power of expression, more power of expression. And normally we're in a fundamental trade-off. So if I want a very simple tool for text editing, I can use a text edit, right? But it doesn't do very much. Or I can go to InDesign, and it does all kinds of complex publishing things for me, but it's at the other point in the curve, and it takes me a lot of time and energy to learn. So as researchers, we view our problem is, how do we balance this power of expression with simplicity of execution from the user's point of view? And the key is that we're not trying to move up and down on that curve. We're trying to create systems that actually move that curve away. We never get away from the trade-off, but we can take things that are already powerful and make them simpler, and we can take things that are simple and make them more powerful. All right, and I'll have to show you some examples, but before I do, I just want to say that we, as the speaker before was saying, we borrow from the real world, the physical world. And so we look at how human beings use physical tools, and we say, well, we can create things like a hammer here, and it has various properties that allows me to hammer a nail, and we use them as they're supposed to be used. So we learn how to use them, great. But we also improvise. So if I don't happen to have a hammer, and I see a shoe that has the appropriate properties, I can use that instead. And because I understand the physical properties as a human being, I understand those capabilities in these objects, I can use them. Now what's also interesting is that I can improvise in the other way. I can turn this tool, this hammer, and treat it as an object. I can treat it here as a different kind of tool, a tool for measuring, right? It's got a height, and I want to use that property. So the question is, why? Well, yes, and we can also use things in really different ways. I like this because it's multiple. It would actually not be a very bad cutting board, an iPad. It just wouldn't work very well as an iPad for very long, but anyway. So we have these physical tools, and we appropriate them, and we're in a situation where any object can become an instrument, and any instrument can solve multiple problems. So we just have a series of things you can do with chopsticks, not just eat, but tie back your hair, use it as a drum, make a huge model of Jackie Chan. And the question is, why is our software so brittle? Why is it that it's only designed to do the thing that the programmer decided to have it do, and not have this flexibility and suppleness that we get in the physical world? Well, if we look at the history of where our computer systems today come from, we see that the graphical user interface, the GUI, was designed by Xerox in the 1970s. And she is the epitome of the target audience. She's somebody who's high enough up in the hierarchy that she's got her own technology, but her job is to copy things. The goal of her task is to make things done more efficiently. The reason all of you work with documents, files, folders, cut and paste, trash cans, those are all metaphors that come from her work in the 1970s. And so if you look at what happened is you've got this focus on tools and efficiency and doing that task faster, but not composition, not creation, not trying to do something new. So if you look where we are on the desktop, it hasn't changed very much. It's much more colorful, I'll give you that. It's actually more cumbersome. There are things in the Xerox Star from the 1970s that are more powerful and more coherent than what we have in your traditional desktop, whether it's Apple or a PC or even a Linux or Unix system. So I'm going to shift my focus right down and give you a set of very simple examples of how you can rethink the way you interact with your phone. And I don't have my phone in my hand. Yes, normally I have my phone. Imagine I have a phone. All of you have a phone, all of you. And you all use this kind of interface, right? You have buttons, you have pull-down menus, all right? Now, if you think about it, as a tool, as a piece of hardware, it's extraordinary. That piece of technology is far more powerful than what put a man on the moon. And it's in your pocket. It has a beautiful high-resolution display. It's touch-sensitive. It can detect acceleration and movement. It has a camera. Incredible piece of hardware. Also, your hands. Your hands are incredible, right? You can do all kinds of things with your hands. They're very dexterous. And how do you interact with your phone, which you use every day, for hours every day? You tap, you drag, you swipe, and you pinch, and that's it. So we've taken this incredibly powerful object and incredibly dexterous hands and brains and so on, and we've made this sort of bottleneck with this very limited interaction in between the two. Think about how we interact with the physical world, the kinds of tools, the kinds of things we can do, playing a violin, sculpting, cooking. Those are all things where we have the ability to learn and get better over time. Every morning I sit on the metro as I go into work, and I see everybody around, about 3/4 of the people around me are doing something on their phone. They spend hours on the phone. Imagine if you spend as much time learning, but just practicing the piano as you do on your phone. I'm not sure you get to be Lang Lang, but you would have a tremendous level of skill that you don't have. The problem we have right now with phones is you don't get better. That interface is fundamentally limited. You can't grow with it. It's not a partnership. So what we want is to be able to think about how do we make something that simple maintain its simplicity so that everybody in the general public can use it, but also have a higher ceiling, move upward, have greater power of expression. So, one solution to this, and there are a number of different things we can do. I'm just giving you one example that is sort of a coherent series of things. But we can use gesture-based commands. So if I have my phone in my hand, I can do a gesture. I have motor memory, I have proprioception. If I have a command that lets me do something I want to do, I can just do it with my thumb without looking in the dark. You are all in there. You don't have to look at your phone and tap. You can just do it, right? So gestures give us a lot of benefits that we don't have right now. So why don't we have complex gesture-based interaction on the phone? Well, the problem is that you have to learn it. So we know that they're out there, but we need to be able to discover those things. We need to discover those gestures. What do they mean? We also want to be able to appropriate that and express things, but I will get to that in a minute. Anyway, so people adapt to technology. I've shifted into a different topic here. So The idea of a human-computer partnership is what we call a co-adaptive system. This is another term that's borrowed from biology, and the idea initially is that if you look at evolution over the millennia, it's not the case that the environment was static. In fact, the organisms in the environment radically changed the environment over time. So we started out with anaerobic bacteria, and those generated oxygen. And after a while, there was enough oxygen that other bacteria were able to evolve that treated that as input, and then you started getting this much more complex environment over time. And that happens on a very small level as well. So for example, in industrial London, there are a bunch of moths that could be sort of black, white, gray, whatever. As London got darker and grittier and grimier, the white ones sort of disappeared and the dark gray ones were everywhere. And then when they cleaned up the city, the white ones came back. So they're adapting to the environment. So there's this whole notion of adaptation in both directions. We both adapt to the environment that we're in, but we actively change it, and we treat it as an environment for future interaction. So, if I go back to my gesture-based commands example, the key challenge is, how do I learn these gestures? How do I know what this gesture means? Aren't I just going to forget them? Well, what we want is something where an expert just performs the gesture without being slowed down. They just do it. So that's our power of expression. I have a wide variety of different gestures, and an expert can just do it. But what happens if I'm a novice? What do I do? Well, it turns out I do something that's very easy to detect, which is that I hesitate or I pause. And in that case, we create what's called a dynamic guide. This gives us what we call progressive feed forward. So not only do we give feedback about what has been recognized by the system and what did I do as a user, but I also have feed forward, which is what are my options now? And so in this case, you see that in the novice who pauses at the beginning of the gesture can have a cut command, a copy command, and a paste command. If the user pauses halfway through, the paste command has gone away, but the cut command remains and the copy command remains. Notice that the cut command is a little bit thinner. That says it's a little less likely to be recognized by the system. So what we're doing is we're informing the user some fairly complex stuff about what's happening in the algorithm that's recognizing their gestures, but in a way that makes total and utter sense to the user. It's in the user's terms. So let's see what that looks like. Oh, yes. All right. So progressive feed forward tells us which gestures are available, and feedback what has already been recognized. So let me show you the video, and hopefully, there we go. So now we're going to do the help command, which is a question mark. And so we have this going here. I'll try it again here. And you see there's a number of different paths, and then they disappear progressively. We have the novice mode where we show everything. That has problems with overload. Here, intermediate, you just get the ends, and then, of course, as an expert, you just do it. And that goes on. Hello. There we go. Now, earlier I showed you some examples of people appropriating tools. So taking the chopsticks and using them as drumsticks, or a shoe and using it as a hammer. So what would it mean to start doing that in this kind of environment? Well, one of the first things you'd like to be able to do is create your own commands. So we have something we call field word, which is a feed forward technique. And if you think about it, if I'm going to do a command that I add, so say I call my mom every day, and I want to be able to just do that on my phone without looking at it. I want to have a gesture that's easy for me to remember, and at the same time, easy for the system to recognize. It needs to be a unique command. It needs to be a command that isn't confused with other commands. So how do we communicate that to the user? Well, we have a very simple system called field word. And the idea is that we have a field that ranges between red and blue. If I draw a gesture and it ends in a red zone, that means that the gesture already exists. So that's actually interesting because it tells me several things here. One, I better keep moving or try a different gesture because this one is already recognized. And secondly, it tells me that that gesture exists in the command set. The second thing I do is, okay, if it ends in a blue zone, then it will be recognized. That's it. Very simple. Let me show you how that works. Okay, here he's registering a command for set timer. He's typed in set timer, and now he's drawing it.
Say I want to draw a clock, but it already exists.
Yes, I don't need the sound except in the very end. Okay, now he's doing gesture. It ended in red because we'd already defined it, and now it goes off and keeps going. So the idea here is that we have this very, very simple way of communicating to the user what's going on under the hood with the algorithm and letting them create their own things that make sense to them as users. On the software side, I don't need to know what's going on in the user's head. I don't need to know why they think that that's a good gesture to remember for set timer. All I need to know is that it's unique and that they've chosen it. So, let me go again. Here we go. Now, let's say we have this system where we can actually create our own commands and we can figure out which ones are available or not. Now what we want to do is to be able to have a much greater power of expression from the cell phone. To do that, we need to have access to the commands. I suspect most of you have worked with command line interfaces. So the question is, how do you get a command line interface in a simple way on the phone without losing all the simplicity that we currently have? So we have something that we call command board. And here, the idea is that we use something called gesture typing, which I think I'll explain more. And the idea is that we take the space above the keyboard, a soft keyboard, which can go anywhere, and instead of having that be a dead space, just an output space, we make it a secondary input space. And so we transform the soft keyboard into an environment where we can issue commands on the phone and then actively interact with them. So let me show you this here. All right, so let me break that down. So I type the word doodle, and then I do execute. Oops, why is this continuing to, I want it to stop. All right. Yeah, all right, sorry, all right, I'll just see if I can stop it there. All right, well, imagine that I've typed the word doodle and I go execute. That's all. Any command that's available on the phone, I can just type the name and go execute. That's faster than going and trying to figure out which set of menus it's hiding in and go through and pull down the menu and the hierarchy and so on. I can just type it and go. And just like there's a search bar for words, we have a command bar, so that's a much more restricted one. And in the particular context I'm in, there's a limited set of commands. So I can start typing the word. It fills in and gives me the suggestions of the likely command. Once I get what I want, I execute it. All right? Now, you saw some other things. I'm sorry, this is doing the full videos each time. So here we have doodle, execute, and now he's saying, I miss you, and now he's in the doodle mode and drawing. The next thing we do is we have a parameterized menu that appears. Ugh, this is frustrating. Okay, that launches doodle. Let me see if I can do this. Yes, we're just doing, all right, there we go. I don't know how to pause. Maybe I can pause. Can I pause? All right, this will do. So here we have the Octopocus, the dynamic guide that you saw before, but integrated. So if I am not entirely sure of all the parameters that are associated with a command, I can move up and choose those. I can also find a command in this way, and I can also find a direct gesture where I do the command from the command board, and just as I was talking about in the general space, we can do that from the command board. All right, so this is discovering the strike-through command. I slept through the lecture. Yeah, decided not to do that, and so I love the lecture, right? And so you see what we're doing is something where we just have it integral in the movement by the user. All right, and there we go. somehow I'm sorry, all the videos have they were cropped and they're not now. All right, so if you think about what's going on from an AI point of view, the machine learning algorithm's goal is to classify the correct word. And there's a tremendous amount of effort trying to figure out, based on your previous history, what other people have done, crowdsource, massive amounts of data being focused on trying to figure out what your next word is going to be. And it's often wrong, and you correct it, and on you go, okay? But the entire way the question is framed is the only goal is to classify that word. And I would argue that treating all of the human variation that you get in the gesture is actually kind of a shame. It's treated as noise that we throw away. So I'll show you another way of appropriating or being expressive with your typing. So these are using the gesture typing technique. All of those are variations of the word great. You can see the G-R-E-A-T. All of those gestures are accurately defined as great, which is extraordinary from an AI point of view, I think. Now, the thing is, from a human being's point of view, they're all unique. So each user who did that has everything that they created squeezed out, anything that's personal, and the result is one typeset word great. That might be what you want, but sometimes you want to have it vary. So here we see pepper, pepper, and pepper. Those are all the same. And now what we do is we look at the shape, the characteristics of how the user draws these things, and we translate that into expressive output. So we can change the color, we can change the expression on emojis, and we can do expressive typography. So here's an example. You see somebody normal typing with your fingers. You just type. Here you go. And then if we can generate expressive text, that's colorful. Here you see she's writing, we're going to the restaurant, I think it's going to say. So she's changing the color and changing the style of the text. She's talking to her kids. And so she's using a font that is a kid's font. And she can do that under her control. So we've done tests with this, and people can actually do this under their control. So this is what's going on. Instead of what we have on the left, which is just throwing away the variation, we do feature analysis, and we look at the curviness, the speed variation, and the size, and we turn that, we map that to RGB in the RGB color space, and the users can now create any color, and they can do it reliably just by changing how they draw. So as you write, you control this. And let me see here. So this is what we're doing. We're working with a professional typographer at the moment, and the idea is that you can dynamically change the typography as you go and add emphasis and so on in the context of actually working. So we have, this one is mapped to, can be mapped to an accelerometer, or you're on the bus and it's bumping, whatever you like. All right. So in this case, we've got this idea that we'd like to change the kind of relationship that we have with users so that we've got more of a understanding of what's happening on the computer side and more power without losing simplicity on the user side. So now I'd like to, that was all done with the phone. I'm going to show you another set of these kind of principles of discoverability, appropriability, and expressivity, but applied in a very different area. So we've been working with what we call interactive paper, and we've done a lot of work with musicians at IRCAM in Paris, if you know. It's a contemporary music center. And this is what musicians do. They do not just, composers, excuse me. They don't just write notes on a score. They actually create their own styles of thinking about what the music should be. They create their own languages. And what happens when they have to put that into a computer system is that they have to translate this very creative, unique per person way of thinking into patches in open music or various other kinds of computational systems. So what we're doing is we're taking creative professionals and turning them into input devices for complex software. And it seems like the challenge for us is how do we let them do the kind of creative expression that they want to do and still obtain the benefits of a computational system. And what's particularly striking of them, I should just say we do a lot of work with our actual users. So we go in and we interview them, we observe them, we do what are called participatory design workshops with them. And one of the things we see is, imagine there are 30 different composers, and you find the perfect tool for one of them. The next one, sitting next to him, will not use it because each person has to be unique. They have to have their own special way of thinking about their composition practice. And if you think about, like we saw things, there were people who would draw lines and then slice them, organic lines, and slice them, and that would be determining the rhythm. Or he used a magic square and calculated things from that. Another one had the same paragraph from Goethe, and he used it for 20 years as an inspiration for his compositions. Another one looks at the shapes of the letters and turns that into music. So there's all of these different things. How do you create one tool that's going to work for all of these different people? Well, you don't think about the mechanics of translating what they do into a computational system. You think about creating an environment that is close to what they already want to use, which is pen on paper, and drawing, and then transforming that into something that they can use. All right, so one thing that we did, as an example, there's a whole series of things, but I'm just doing a short version of this. Euler has something called a tonance. And a tonance is a way of analyzing the relationships among different pitches or tones in a hexagonal shape, a two-dimensional square. And then you can link that, well, actually, it was used for years, centuries actually, to analyze music. So analyzing Beethoven or Bach and looking at the patterns that they have and offsetting them. So it was used as an analytical tool. And then one composer at IRCAM decided to use it as a composition tool. And so what we did was we created a paper, what we call a substrate, that you can draw in this space and generate music, like tie it into a system called Open Music, which they developed there. So here's an example. And now I need sound. Okay. Each of these, notice it says C minor melody. You can put different scales, different clefs, different instruments, and it persists. So it's something that I could use and replay. Now what he's going to do is work with multiple tones together, so that becomes a chord. All right, and now, graphically, some of these have the same visual pattern, and you can offset them in different places. And that is going to come up again. Here, he's looking for another place, and he can get, right? And in drawing, he's got the timing with it, but you can adjust the timing. What he's doing right now is exploring this space of how he wants to make it. And then, basically, you can assemble this the pieces here. And this, by the way, is an Anodo pen. I don't know if you're familiar with it, but there's a dot pattern that gives a unique set of dots on the paper. You just print it with a printer. And then in the pen, there's a tiny camera and a little screen, and you can embed, you can capture every gesture from that pen with the timing and so on. Now we're going to hear, I think. So this was actually done by a composer who was explaining this, exploring this. If you hand this to kids, they write their name and hear what their name sounds like. And if you give it to professional musicians, they explore it. So it has this wonderful simplicity of use from the initial what has happened? Here we go. To extreme power of expression. Here's another one that I like. This is probably the simplest bit of programming that you can do. Basically, there's the pen again, the Enoto pen. You draw a knot. It's 100% accurate in terms of recognition, so it's very easy to recognize. You draw a line, you put a knot on it, and then you apply a function from the pen, and you can interact now or later. So here's an example. You can define mathematical relationships. I can draw a series of numbers, can recognize the numbers. I can draw another line, say calculate it, and so on. I'll show you another example. We can draw a line with a knot, choose recording, make this a recording here, and then identify the start of the recording, the end, and then you can scrub back and forth and play the recording. So imagine you're taking your notes on paper, and you can get the sound of the lecture or music or whatever you want. And this should be, hello, should be playing. There we go. Here he's doing some, I think he's doing, yeah, he's choosing square root. No, he's choosing sine. Drawing a line, adding a dot, and then he's doing another one. So basically, you have a set of functions that are downloaded into the pen, and then there's a Bluetooth connection to the computer, so you can have certain things done in the pen and other things that are done at a distance. And here what it's doing is it's calculating, so you just touch it, you write it down, and he sees in the screen the answer. So he's creating his own dynamic space for interacting, okay? I think I'll keep going here. Now, there's another thing, which is how do you create expressive output? So here we have a really interesting project done with Philippe Leroux, who's a world-famous composer. And he's working with musical scores like this. These are from the 13th century, and it's interesting to look at them because they're before scores had been standardized with the usual notes that we see and the standard way. So if you see these little flags on each note, that's a form of expression. That's how you're supposed to play that note. So in this case up here, it's, I guess, a very dynamic thing. And then other ones, there's no expression at all, so maybe short and choppy. So what he wanted to do is use this as inspiration for a modern composition. And so he worked with one of my graduate students, Jeremy Garcia, and we put together a system where you take a copy of the score, and then you have this in a pen, and you draw over elements of the score that you like, notes, and so on. And again, as we saw before, we can capture a lot of different things about human movement. We can capture the speed variation, the shape, and map that onto different features in the composition. So this is Quid Sit Musicus.
Graphisme du manuscrit et lui donner un sens nouveau en utilisant toutes les données qu'on peut en extraire, c'est-à-dire par exemple l'épaisseur du trait.
So we're tracing the original manuscript here, and that appears in the electronic form using the software to record the information describing the nature of the gesture. This is Open Music. And so it's sent to the program. These are patches in Open Music. And you can see it interprets the shape of the gesture in this particular case.
Donc il correspond sur la partition sur le manuscrit de Machaut qui correspond à cet élément-là.
So Machaut is the name of the original composer.
Nous donne donc des trajectoires
And there's the trajectory
qui sont utilisées là directement par les voix sous forme de glissée. On part cette fois d'un neume qui est un punctum.
See that shape is the shape that was drawn.
Et
and
qui
it
donne
shows
donc
up
ces
in the notes
trajectoires-là.
Here. And then it's
Si
stretched
je les lis
out.
de façon un peu plus dilatée, elles sont comme ça. Et donc là, ce sont le violoncelle et la guitare en fait qui suivent exactement les contours de ce neume.
Now I imagine that the original score did not sound like that. But it's interesting as a device, there's sort of endless human ingenuity in terms of how do they create and reinterpret information that they get, and then create something new and express themselves. So the question for him was not, he has a musical assistant who can program things directly into open music. He doesn't program it all himself. But having the ability to draw and interact with paper and make choices about how that gets interpreted and different ways of putting together became a very powerful tool for him as a composer. So, one last slide. So basically my argument to you, especially those of you who are building technology, is don't forget the role of the human user in that loop. The user is not just input to an algorithm, but rather the person who should be in control, and you should be revealing what's happening in ways, not necessarily explaining it in technical terms, but revealing what's happening in ways that the user can react to and use productively to create what they want to do. So we want to empower users, we want to not frustrate them, and we definitely don't want to replace them. So I will stop there and ask for questions. Thank you.